This is the lecture number 8. Again I am just telling you, if you are just coming in this lecture, at first you must go in the previous lecture, in the lecture 5, 6, 7, okay, then it will be clear. So in this question we have to prove that this is a basis or not. For basis you have to prove the linearly independent and spanning, okay. At first I will show that linearly independent. For the linearly independent, let we are just taking that this is B1 and this is B2 and this is B3. These are the vectors. We have to show that these vectors are linearly independent. For linearly independent, you must have alpha 1 V1 plus alpha 2 V2 plus alpha 3 V3 is equal to 0. So the linearly combination of scalar and vector is 0 if all the scalars are 0. In the linear combinations, if all the scalars are 0, then these vectors are linearly independent, okay. So now we will put this alpha 1, I don't know, we have to prove, we have to find the value of alpha 1. Our task, we have to find the value of alpha 1, alpha 2, alpha 3. This value they have given us, okay. If alpha 1, alpha 2, alpha 3 all are 0, then this will be linearly independent. If not 0, then this will be these vectors are linearly dependent, okay. So alpha 1, what is V1? V1 is equal to 4, 3 minus 2, then plus alpha 2, okay. V2 is equal to 2, 1, 0 plus alpha 3 into V3 is equal to minus 1, 1 minus 1 is equal to 0, okay. So now you will multiply this here, 4 into alpha 1 plus 2 into alpha 2 plus minus, sorry, this is minus alpha 3, okay. Then after then comma, first then comma, here is also after first comma, so you will multiply this here, 3 alpha 1, you will multiply here plus, okay, plus alpha 2, multiply this here, then you are getting plus alpha 3, okay. Then you know that after then comma, then multiply this here, minus 2 alpha 1 and multiply here 0, okay, multiply here minus, plus minus is equal to minus alpha 3 is equal to 0, okay. Some student maybe they are facing problems, what we are doing actually. If you are facing any problem, you can multiply. What we are getting, alpha 1 into 4, this will multiply here, okay. So you are getting 4 alpha 1, okay, comma 3 alpha 1, okay, comma minus 2 alpha 1. This is the first one. Then here is a positive, okay. You will multiply here, then you are getting 2 alpha 2, comma alpha 2, comma 0, okay. Then you are multiply this here, then you are getting plus minus alpha 3, okay, comma alpha 3, comma minus alpha 3, okay. So whenever the first one you have to add, okay, then the second one you have to add, then the third one you have to add, then you will add second one, okay. This you can see that the second one, after then there is a comma, okay. Then the third one you can see. Your concept, I think that it must be clear, okay. I think that it is clear, okay. So what we have done, this 4 alpha 1 plus, after then you can see that the plus, it means that plus 2 alpha 2 plus minus alpha 3. This is the first one. Whenever you have taken the first one, then there is a comma, so the comma will come. The first one, 3 alpha 1 plus alpha 2 plus alpha 3. The second one we have taken comma, so there will be also comma. Then the third one, 2 alpha 1, okay, then plus 0, okay, then plus minus is equal to minus alpha 3. So this is the way to solve. If you are just facing again a problem, pause the video, again watch it, then it will be clear. So after then we have written it. Okay, here 0, it means that you can also write 0, 0, 0. No problem. Okay, both are same. So now compare, this is equal to 0, this is equal to 0, this is equal to 0. So you are getting 4 alpha 1 plus 2 alpha 2 minus alpha 3 is equal to 0. This is also 0. 3 alpha 1 plus alpha 2 plus alpha 3 is equal to 0. This also 0. Minus 2 alpha 1 minus alpha 3 is equal to 0. Now you have to solve it. Okay, you can see that by the help of this, you can see that 2 alpha 1 is equal to minus alpha 3. Okay, it will come here. Okay, so alpha 1 is equal to something you will write. Okay, then put the value here and here. After then you can also cancel something. Multiply, you will multiply 2 alpha 2 will be cancelled, and alpha 2 put the value here, then after then you will get something. So I will tell you, if you will just solve it, then you will get, if you will solve it, then you will get alpha 1 is equal to alpha 2 is equal to alpha 3 is equal to 0. That is your task to solve the question. Okay, that is the high school. Okay, all are 0. If all are 0, it implies that V1, V2, V3 are linearly independent. Our first target, it has completed. Now we have to find the second target, that is the spanning. Whether it is spanning or not. For spanning, what will you do? You will take any vector. We have to generate any vector by the help of these vector. Okay, so alpha 1, this is V1, 4, 3 minus 2 plus alpha 2. Okay, 2, 1, 0 plus alpha 3 minus 1, 1 and minus 1. Okay, so again I am just again solving the same thing. So already we have solved 4. If you multiply this, you will solve it, then again you will get the same thing. Okay, so 4 alpha 1 plus 2 alpha 2 minus alpha 3, then you will get comma, then after then 3 alpha 1 plus alpha 2 plus alpha 3, then after then minus 2 alpha 1 minus alpha 3. We have written this all. Now compare with this element, then you will get 4 alpha 1 compare plus 2 alpha 2 minus alpha 3 is equal to x. Then the second one, this 3 alpha 1 plus alpha 2 plus alpha 3 is equal to y. Okay, then at last minus 2 alpha 1 minus alpha 3 is equal to z, If you will solve all the all the equations, then you will get this. Alpha 1 is equal to, you will get 1 upon 8 minus x plus 2y plus 3z. Okay, alpha 2 is equal to, if you will solve it, this is your problem to solve it, that is the high school. Okay, so after then you will get 1 upon 8. If you are just facing any problem, then go in your previous lecture matrix. Okay, then your problem it will be solved. So this will be 5x minus 2y minus 23z. Already I have solved. Alpha 3 is equal to 1 upon 8. Okay, sorry, actually this is 1 upon 4. Okay, 1 upon 4 minus x plus 2y plus 7z. If we have find alpha 1, alpha 2, alpha 3, okay, we have find alpha 1, alpha 2, alpha 3, okay, in the form of this, it implies that this xyz can be generated by the help of this scalar and vector. If any vector can be generated, any vector, it means that you can put any value here. These are the free variable x, y, z. Okay, any value, any variable. If any vector can be generated by the help of scalar and vector. Okay, it means that this is the span. Okay, it means that you have proved this linearly independent and span. It means that this is the basis. These vectors are the basis. Okay, so that is the way. Okay, if you are just again facing any problem, go in the previous lecture, lecture number 7. Lecture number 7 already we have discussed. Lecture number 8 already we have discussed also same. And to come in the lecture number 7 and 8, at first you must cover lecture number 6, 5 and 6. Okay, Okay, I have made the series lecture number 1 to 12. Okay, just complete all series, then your all concept it will be clear. Thank you so much.